Hey, good afternoon, class. Mr. Bean here. I had to redo the YouTube video. I made an error, typo. I squared something when I shouldn't have, and I want to make sure we get that kind of squared away. Anyway, so this is pre-response review number 2, Newton's laws and gravity or circular motion. And I want to go ahead and take a look at this question here. We'll let you go ahead and read the question. And so what I'm going to do is, what I have in yellow is what the actual solution is. So up here, I have some thoughts of what I'm thinking out. So here I have a block, and it's moving to the right with positive VO. We have Fn acting upwards. We have mg acting downwards. And force of friction is going to be opposing motion. Okay, that's the only force acting in the horizontal direction. And we're also given information that the mass of block A is 2 times that of mass of block B. If you need to, you can draw it out here to give you more clear picture. Now up here is just my thought process, because it says to explain here, student 1 says block A will slide farther along the table before coming to rest. What reasoning would support this prediction? Okay, do not use an equation and state the reasoning conceptually. Okay, so what I'm thinking here is, here I have horizontal direction, here I have vertical direction, up equals down, Fn equals mg, and here's the x direction, sum of the forces equals ma. And notice here, we have force of friction is mu Fn, and Fn, of course, is mg, make a substitution, and notice that's negative, right? And notice the masses do cancel out, so acceleration is equal to negative mu g. So that's the term for acceleration here, okay, decelerating. Notice here the mass cancels out, okay? So whether it's twice the mass or 1 times the mass, doesn't seem to have an effect here. Now, we could use conservation of energy, or we can use the kinematic equations. Since time is not given, we'll go ahead and use this formula here. V squared equals VO squared plus 2A delta X. Okay, VO final is going to be 0. Make the substitution in here for acceleration. Do some algebra, and I have that delta X, or the distance traveled, is VO squared divided by 2 mu G. So you can see here, mass is not involved at all. It only depends on initial speed, coefficient of friction, and gravity. This applies to both blocks. So now with this in mind here, I'm ready to answer the question. So here, why would a student 1 say block A will go further? Okay, we can say here block A has more inertia, has more mass, so it will resist slowing down more. Okay, think about that. If that's confusing, let me know. We can talk about it some more. II here asks, student 2 says block B will slide further. What's the reasoning? Well, block B has a smaller frictional force acting on it because the mass is smaller, okay? So its motion will change more slowly, okay? And let's go and take a quick look here. Take a look at part C here. And it says to derive an expression, or does the expression you derived in, B, derive a mathematical expression you could use to find the distance traveled by the block. Well, that will be up here. Okay, we already kind of did it here using we're using kinematic equations, but you could also use potential energy, right? Original plus kinetic energy initial, right? Minus any work done by friction has to equal potential energy final plus kinetic energy final. Okay, so if I do this here, it will kind of help you out a little bit. On the right side, this is going to be 0, right? And there's no potential energy here, so that's 0. So basically, you have kinetic energy minus work done by friction. So if you use this, you should get the same answer as seen right here. Okay. In fact, you will get the same answer. Okay. All right. And then finally, let's go ahead and scroll down here a little bit more. See here, does the expression you derived in B support your reasoning you used in part A to support either student 1 or student 2 or both? Explain briefly. Okay, so I go over here. the basic key is mass cancels out and does not affect acceleration. So that will be the basic idea or the basic tenet that you have to make sure you have that on there. Okay. All right, so we'll go ahead and scroll down some more here. And here we have this problem here. Now, some people, I did some grading here, and people think that this is a vertical situation. You are looking down at a top of a desk, okay? So you're looking down at the top of a desk here, okay? And so I'll let you do the reading here. And while you're doing the reading here, I think you have like 13 minutes to do this one here. Okay, so I'm just doing thoughts to myself here, sketching out some ideas. Now notice here, the width of the block here is D, okay? So L is the radius plus this little part D, but we have to go to the center of mass, which would be D divided by 2, center of mass, okay? So I think it's going to kind of go like this, right? But there is friction, okay? Friction is going to cause this to slow down and perhaps lose some tension here. Okay, here's the formula for centripetal force right here. And this time, the force of tension is going to supply the centripetal force, okay? And the radius here is going to be L plus D divided by 2, okay? Now, some things to note here. When you're at maximum velocity or maximum speed, you'll have maximum tension, okay? Friction will cause it to slow down, thus reducing tension. So this is thoughts in the back of my head. So now to answer the question here, we could say, to answer this question right here, let me, okay, write this question right here. Okay, says explain some things, write an equation. Maximum tension occurs at initial velocity where it is maximum also. As the block moves across the table, it begins to slow down due to friction. Okay, so some of the forces is going to be tension, and tension supplies the centripetal force. So it's mv squared over r. Earlier, I had a 2 here, which shouldn't have been there. And radius is L plus 1/2 of d. So putting the substitutions in, this here will be the equation that you need to show to get the points. Okay, let's go ahead and clear the diagrams and scroll down a little bit more here. Okay. Let's go to mouse here. Okay, let's go to here. Okay, qualitative describe how tension in the string changes during the motion and explain. Okay, let's go over here. Now I kind of already did that up here. Okay, tension will decrease because the block will begin to slow down due to friction. The block may not complete a full circle, but we may want to add that maximum tension only occurs at initial velocity where it is maximum also. Okay, so those are some ideas that you want to include in your description here. Okay, in fact, I may want to add this part here probably should be added down here too as well. Okay, all right, let's go ahead and clear all the drawings here, and let's scroll down to the next question here. Okay, here's some stuff here about an elevator ride. I'll go ahead and let you read the question here, and let's see how we can answer this question without using an equation. Okay. All right, so what I am thinking to myself here, before I start the answering process here, I'm going to provide some ideas to myself here. So we have 15 minutes to answer this question. So at rest here, here's an elevator here. Velocity is 0, so acceleration is 0. Okay, normal force is going up, mg is going down. The vector arrows are about the same size, so sum of the forces equals ma. Normal force minus mg equals 0, and 0 is because acceleration equals 0. Therefore, Fn equals mg. Now, as the motion is going upward, what happens is that we have acceleration as positive going up. Okay, we still have normal force going up, mg going down. Now, this time what happens is that we have normal force here minus mg is equal to ma. This ma term is here. When I solve for Fm, which is the apparent force or apparent weight, we see that we have here m parenthesis g plus a. So we have an additional force of ma acting here. So taking these ideas here, let's go ahead and see how we might be able to answer question A here. The student's mass has inertia and wants to remain at rest. An unbalanced force is needed to cause acceleration. While at rest, the student's weight is balanced by normal force of the floor. During acceleration, the student experiences acceleration, which adds an unbalanced force. This unbalanced force can be additive or subtractive. This causes the apparent weight gain or loss. Okay, that's pretty good there for question A. B says, draw a free body diagram when it's accelerating upward, moving at constant velocity, and finally when it's accelerating downward. Okay, so here I have mg going down. The normal force, well, let's take a look here just to let us know here. Here's the normal force here. We'll make the normal force there, like so we see as normal, and we'll make mg right here. Okay. All right, so this will be normal force. This is mg. So when accelerating upward, we have to go a little bit higher here to show that there's a net force going upward. So acceleration is caused by an unbalanced force. Velocity is constant. The arrows should be the same size. Fn going this way, mg going this way. They need to be the same size. And when you're accelerating downward, there's still a normal force here, but the force, total force going down is unbalanced. There's a little bit more due to the acceleration. Okay. Then finally here, sketch acceleration versus time, velocity versus time, and displacement versus time of the student during the entire elevator ride. Okay, the key note here is the time. Look at 2 seconds, something's happening at 2 seconds, then is a constant rest for 10 seconds, which brings us to 12, and then something happens in the next 2 seconds, okay? So I would keep track of 2, 12, and 14, 2, 12, and 14, 2, 12, and 14. So when it's accelerating upward, it has a positive acceleration, constant, okay? Then it's moving at constant rate, so there's no acceleration for 10 seconds. And then it's decelerating, negative, so we put negative here for the remaining 2 seconds. This is for acceleration. And velocity is going to be linear or straight for the first 2 seconds, right, until it reaches maximum velocity. And then acceleration is 0, therefore it's going to be flat here for the next 10 seconds. And then we're going to slow down back to 0. So we need to have a negative slope here, okay? Now, the total distance y, okay, we got to be careful here. In the first 2 seconds is accelerating, so this needs to be a non-linear curve, non-linear, okay? Then for the next 10 seconds is linear, and then finally for the next 2 seconds it's slowing down, so it has to be non-linear as well, okay? So this will hopefully get you going in the free response part 2, and or the solutions for free response review number 2. And that is it. Any questions, please let me know. Okay, let's go ahead and hit stop here.